So for the next one, I got started on the solution a little bit. So with the diagram, based off of a number of subintervals being 8, we took the same region of 0 to 2 and the same parabola, split it up into 8 intervals. All right, so that's going to give us, instead of going from 0 to 1/2, that's going to make us go from 0 to 1/4 for our delta x. All right, and so that's going to give us smaller rectangles. All right, so our delta x is going to be 1/4. All right, so the values that would be important here, if we look at the diagram, and I'll highlight all the relevant ones, would be the 0, the 1/4, the half, the 3/4, the 1, the 5/4, the 3/2, and the 7/4. All right. If we square each of those by plugging them into the original function, we get 0, 1/16, 1/4, 9/16, 1, 25/16, 9/4, and 49/16. Right. So then the next step in the process is to multiply by delta x being 1/4. So that's where these values come from, my terrible penmanship. And then we would add those together. All right, so let me just crank that out real quick. So I'll neglect the 0. The 1 divided by 64 plus 1 divided by 16 plus 9 divided by 64 plus 1/4 plus 25 over 64 plus 9/16 plus 49/64. All right, so that's going to give us a 2.1875. All right, so 2.1875 on the low bound. All right, so we're going to do the same thing from right to left. All right, so I already took care of the diagram there. Same ingredients, it's just we're starting on the right hand side. All right, so all of these points would be the relevant ones. All right, so instead of the 0, we're going to incorporate the 2. All right, so a lot of copy paste, which is why, well, one of the reasons why I was able to kind of get a little sneaky here. So I'm going to take all of this stuff here. And I'm going to tack on a 2. Squared becomes a 4. Multiplied by 1/4 becomes 4 times a quarter is going to be 1. So I'm just adding a 1 to this. Alright, so now we're looking at an upper bound of 3.1875. So even between the last example and this one, you see it goes much quicker. I mean, the copy pasting aside, that's just me using the technology. It doesn't always, translate to pencil paper, but you could see though that the calculator work is a lot quicker because you're running off of the same computations as long as you have an idea of the concept. Right? So it's removing one endpoint and introducing another. Right. But the question still stands: who wants to do this for n equals 16, 32, and 256? We need a better way.